All right, 3.5, solving quadratics by using the quadratic formula. Okay, so let's just read through this a little bit. Students will be able to solve quadratic equations by using the quadratic formula. Easy, I'll show you how to do that. Some quadratics are just more annoying than others. So there's some that are just harder to use, where we can't use factoring very easily, or we can't just take the square root, or we can complete the square, but it's kind of tedious. In fact, quadratic formula really is just a formula derived from completing the square. So to deal with all of that, to deal with any quadratic ever, we have the quadratic formula. And here's the quadratic formula here. I'm going to highlight it for you just so you have some space. You might want to highlight it on your notes somewhere. That is the quadratic formula. But I have this little story to help you remember it. There once was an emo boy, negative b, who wasn't sure whether or not, that's the plus or minus, to go to this radical party, that's the square root symbol, or b square and miss out on 4 awesome chicks. So b squared minus 4ac, b squared and miss out on 4 awesome chicks. And the party was all over at 2 a.m. because the party is all over 2 a.m. So here we got negative an emo boy, whether or not, go to radical party, or b square and miss out on 4 awesome chicks, and it's all over at 2 a.m. All the point of that silly story is to help you. If it helps you remember the formula, great. If it doesn't matter. It's just there to help you remember it. Okay, so we have this whole equation that we put together, and it gives us this. Remember, this is when we have an equation in this format. ax squared plus bx plus c. That's what the a, b, and c, they all come from this equation. So if you start here, you just put your a, b, and c in this equation, and boom, we have our answer. Very important here that a lot of students forget. It has to be equal to 0. If it's not equal to 0, you cannot use the quadratic formula. You have to set it equal to 0 first. So let's go through this. The way that I like to do this is I like to do the discriminant, and the discriminant is the part inside the square root first. So let's take a look at example 1 and give it a shot. Example 1, remember the discriminant, b squared minus 4. Actually, I guess I can make that 2 as well. And then I'll make the a red, and I'll make the c green, okay? So the reason why I did that is I just want to clearly show you. There's your a, there's your b, there's your c. So it's really easy to know what to plug in where. So if the b is 9, we're going to do 9 squared minus 4, parentheses, the a is 7, parentheses, the c is, and this is where some students make a mistake. See, that's a minus 5, so really that's a negative 5. Because if you look up in this equation up here, it says the format needs to be plus and plus. So we're assuming these are positive. If it's a minus, then we have to make it a negative. All right, so the c, the c part is negative 5. All right, so 9 squared, that gives me 81 minus, I'm going to kind of just multiply this all together in my calculator. So another way to think about this, by the way, this is kind of like thinking of it as a plus and negative 4, because you're going to be multiplying it anyway. So negative 4 times negative 5, I'm doing these two because I like to do the negatives together. Negative 4 times negative 5 is positive 20, and 20 times 7 would be 140. So you end up with plus 140. And I want to go over that real quick. I just did all of this. I pretty much did this all in my head. So you have a negative 4 times 7 times negative 5. Well, when you have a negative times a negative, it turns into a positive, and that's why this is a plus. A lot of students get messed up there, so just want to be clear. All right, 81 plus 140 is 221, and so the discriminant part is 221. That's not even our answer. That's just the discriminant. The reason why I like to do that first is that's where students make the most mistakes. So that's kind of why I like to do that first. So now let's go to the whole, see, b squared minus 4ac. Now let's go to the whole enchilada, the whole formula. I like to rewrite the whole thing. Let's color code it again. It's negative b plus or minus the square root of b squared minus 4 a c all over 2 times a. Okay, well, we've already found the discriminant part, right? It was that. There's maybe a different color. It was that. So when I go to write this all out, I'm just going to go ahead and say, okay, I got, by the way, this is x equals. So I got x equals negative. What was my b again? My b was 9, negative 9, plus or minus the square root of, well, we already know that is 221. Oops, 221. So right there, I'm just going to go ahead and put 221 all over 2 times, what's the a? We know the a is 7, and we're almost done here. So now, what's this? Let's clean this up just a little bit. I got x equals, oops, wrong color, negative 9 plus or minus square root of 221 all over 2 times 7 is 14. Now, I kind of want to know, what is the square root of 221? If I plug that in my calculator, is it nice and neat? It is not. If I plug in just this part, square root of 221, I get like 14 point something. So that is not a nice, neat number. So this is an answer. But, I'll do capital but, is it the best answer? And to do that, we really have to remember how to simplify square roots, right? How do we simplify square roots? Well, I have a whole video on that called Simplify Square Roots, which I will link somewhere either on Schooloop or Google Classroom for you, for those of you guys that feel like you need some review or refreshing on how to simplify square roots, because that's a big part of this. But just a quick little refresher, basically you're looking for the largest perfect square that goes into the number in here. So the largest perfect square that goes into 221. Well, there are no perfect squares that go into 221. And what do I mean by perfect square real quick? I just mean all your, 1 squared is 1. And we don't really care about 1 squared because that doesn't really help us. But 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so on and so on and so on. Well, I've gone through all these numbers. There is not a perfect square that goes in here. I've gone all the way up until I think I got to like 15 squared, and 15 squared is bigger than 221, and none of them go into that nicely. So it turns out that, yes, this is, in fact, the best answer. It's the best answer because you cannot simplify that. However, on the next problem, that's not going to be the case. So what I want you to do is I want you to work it all the way out till you get an answer, and then when you're there, you can unpause the video and see what I do from there. But go ahead and give practice number 1 a try. Okay, so hopefully you were able to get to here, and that is an answer, but like I said before, that's not going to be the best answer. Here's my work. Just to recap real quick, I found the discriminant first. I found out the discriminant is positive 120. So then I take 120, I plug it into the quadratic formula for the whole thing underneath the square root. Then I'm going to figure out my negative b, figure out my a, simplify it down and get to here. So now we have this thing, and we got to figure out if we could simplify this. Well, what we need to look at is, are there any perfect squares that go into 120? And the fact is that there is. There are a lot of, well, I wouldn't say a lot, but there are some perfect squares that go into 120. The biggest one is just 4. So if you were to take out a 4, 120 divided by 4 is 30. And obviously the square root of 4 is 2. So this is 2 square root 30. And that's as simplified as you can go, just to show you. If we break down 30, you would get 6 and 5. And 6 breaks down to 2 and 3. And these are all prime numbers. None of them are perfect squares, so that's why it can't go any farther. So this is the simplification of square root 120. So that means we could rewrite this as negative 8 plus or minus 2 square root 30 over 4. But you might think, okay, good, that's the best answer. But no, not really. And the reason why it's not the best answer is, if you got an answer like this, 2 over 4, would that be the best answer? No, right? It wouldn't, because you could reduce that to 1/2. That would be the best answer, right? So we need to figure out if we can reduce this, and we can. Notice that all the terms, this is a term, this is a term, and this is a term, all the terms are even. And so that means we could actually take a 2 out of everything. If I took a 2 out of here, it'd be negative 4. Take a 2 out of here, it'd be 1. Take a 2 out of here, it'd be 2. So when I reduce this, I get negative 4 plus or minus square root of 30 all over 2. Now that is a reduced answer, and so therefore that is the best answer because we simplified the square root and we reduced it. I know that's a little tedious, some stuff that you got to remember from previous years of math, but that's what we want, is we want the best answer. Okay? All right, let's go on to the next problem here. Sometimes the problem's not going to be in standard form, and so it's best if we rewrite it in standard form to begin with. What do I mean by standard form? Remember up here, I said that needs to look like this with it equaling 0. So where the x squared part comes first, then the x, and then the constant. And so here we could see, okay, this is not in standard form. So we want to rewrite it in standard form. To do that, I would write negative 3x squared plus 2x plus 9 equals 0. And then I could say, okay, there's my a, there's my b, there's my c. Do the same thing. Let's do the discriminant. Remember, that's going to be b squared minus 4ac. So let's plug it all in. My b is 2, so I got 2 squared minus 4, parentheses a, parentheses c. My a is negative 3, and my c is 9. So what does that give me? 2 squared is 4. Negative 4 times negative 3 is positive 12, so this is going to turn into a plus, because I end up with a negative times a positive. And 12 times 9, isn't that 108? If I know my times tables, yeah, it's 108. And then add those together and I get 112. So the discriminant is 112. All right, remember, we find that part first. And then let's go back to the actual quadratic formula, which is negative b plus or minus the square root. And this is where the discriminant goes, right? All over 2 times a. So since the discriminant we already know is 112, I just plug it right in. Just makes my life a little bit easier when I just take the 112 or the whatever the discriminant is and just plug it right in. So what do I get now? I got negative, my b is actually 2 plus or minus the square root of 112 all over 2 times, what's my a? My a is negative 3. All right, let's attempt to simplify this. One of the first things I want to look at, though, is does this simplify? Are there any numbers? Are there any perfect squares that go into 112? I think that 4 goes into 112, so I'm going to start with that. 4 is a perfect square. It's one of the most common ones that you'll see. So if I take 112, I could definitely break that into the square root of 4 times what? What's 112 divided by 4? It's 28. But you know what? I didn't do this the easiest way possible because there's another perfect square inside of 28, right? Isn't 28 really just 4 times 7? So really this is like saying 4 times 4 times 7, or like 2 times 2 times 7. Oops, square root 7. And so that'd be 4 rad 7. That's a simplified answer. What I should have seen, well, it's not really that it's wrong. It's just that it would have been faster if I would have seen that 16 goes into 112. So just to show you how I could have done that quicker, I could have said, you know what? I know that I think 16 goes into it. It goes into it 7 times. So I could just break this into square root 16 times square root 7. The square root of 16 is 4. And so you get 4 rad 7. You get the same thing either way. So let's go back to our actual problem. I'd end up with negative 2 plus or minus 4 square root 7 instead of square root 112. And then 2 times negative 3 is obviously negative 6. Okay, this is a little bit funky here because, yes, we can reduce it like the last one, but we can reduce it by something that makes it's kind of hard to tell. Basically, whenever the top and the bottom are negative, and when I say top, I really only care about the first term because this one is already both positive and negative. So when the top and the bottom are both negative, you could take out a negative from everything, as well as a value. So what if I took out a negative 2, right? So basically, I'm going to take out a negative 2 from everything. Well, wouldn't that make this just a positive 1? If I took a negative 2 out of a plus and a minus, the plus would become negative, the minus would become positive, so it's still just plus or minus. But then a 2 out of a 4 makes a 2. And then take a negative 2 out of 6, and it becomes positive 3. So the best answer is actually positive 1 plus or minus 2 square root 7 all over 3. All right. If you didn't see that and you left the negatives in here, you just have to realize that like it's a negative on the top and the bottom, so they kind of cancel each other out. You don't really need them. It's kind of just extra information. It's not really reduced as much as possible. Now con, I'll just tell you ahead of time, con sometimes doesn't take out these negatives. Why? I'm not really sure. I think that you should. I think the better answer is to cancel out these negatives. But sometimes you might see the answer in like a multiple choice question and they left the negatives in. That's okay. You just want to choose the best answer available. And if there, if what's written in black here wasn't available and they had the negatives in, was available, then just choose that one. That's okay. All right. One more question on this page. It's for you to do. Remember, you're going to need to reorganize it, plug it in the discriminant, then plug it in the quadratic formula. So I'll let you give it a try and then check back when you're ready to check your work. All right. So hopefully you were able to find your discriminant. You got 88 for discriminant. Well, first of all, you should have reorganized this. So that's your A, that's your B, that's your C. Plugged in the quadratic formula, things start to simplify down. You have a square root 88. That breaks down to 2 rad 22. It doesn't break down any further because 22 is 2 times 11. Those are both prime. They're not perfect squares. So that breaks down. Then you can reduce. You can take a 2 out of everything. So you get to here. But I just want to point out that there's a negative on the bottom and there's not on the top. So if I wanted to, I can kind of just move the negative to the top. It's really what you're doing essentially is you're saying, you know what, I'm dividing everything by -1. If I just divided all this by -1, it'd be -2. This would still be both positive and negative, and then now this wouldn't be negative anymore. So these are really equivalent, and so you could see the answer in either form. And on con, you'll probably see it like this, but I would think that this is a more a better version of the answer. If we can have a negative in the numerator as opposed to the denominator, I think that's just a little bit cleaner. It doesn't really matter though, they're the same thing. Just want to kind of show you some of the different ways you might see it. Okay, that's it for this page. There is another video about the discriminant. See you guys in the next video.